All right, so we're live day 2 at JEC, JEC World. Joining me is Cody Sheltra of ReForm Composites Incorporated. He's the co-founder. He's joining me. They're over in Startup Village.
Yeah.
And I've got the location streaming down at the bottom. Maybe you can explain this a little more. Over at Hall 6, HO4-10.
Yeah, right near the entrance, right at the bottom of the escalators.
So just a little background on ReForm. They advance continuous fiber reinforced thermoplastics as the next evolution of composite materials, delivering the strength and durability of traditional composites with added toughness, recyclability, and reformability. Combining deep engineering and research expertise with its continuous forming technology. So, Cody, thanks for spending some time. Thanks for joining me today. Good to see you.
Yeah.
Tell us a little bit about your background before we get started on the company.
Yeah, so I grew up at the University of Maine. Kind of dove right into composites as a first-year undergraduate student at the Advanced Structures and Composites Center. And after I graduated with a mechanical engineering degree, I stayed on as a researcher, and I was there for about 15 years and studied composite material mechanics and manufacturing. And during that time, we invented a hybrid pultrusion technology that we originally invented to create field-bendable thermoplastic rebar that could be heated and bent on site.
Okay.
From there, we kind of realized the versatility of pultrusion, especially paired with the thermoplastic nature and being able to reform the surface of a rod and turn it into rebar or different shapes like that. And through that process, we created ReForm Composites. And,
Yeah, I had the opportunity to talk with, was it Jacob?
Yep.
Jacob, back in back at CAMAX in Orlando. So. So that was good to have him come by. We were talking about the polydowel?
The polydowel.
Yeah. So what is that?
Polydowel, so we're all originally infrastructure researchers, so we kind of have a passion for construction and infrastructure, and we think composites are not taking their full potential in those markets. There's a lot of adoption challenges with new things that could be life critical, obviously. So we target, as we've been working on field bendable rebar, that takes some time. There's some codification hurdles to get through. We targeted dowels as a structural adjacent application with the same material, still concrete. It's technically concrete reinforcement alignment for slab works like sidewalks or warehouse floors, but it's not considered life critical. So if a dowel doesn't do its job, nobody gets hurt necessarily.
Right. So certification's not.
It's a little different. Yeah. But what we found is, or what we were aiming for is, if we get something made of this material, which the material CFRTP's been around for decades, right? But typically not cheap enough to be in a market like construction. So as it's become more popular and prices have gone down, we've been able to target things like construction, and the dowel was our first step of getting something in concrete that could build some confidence. And first dowels were installed in a high traffic entertainment location in Florida in 2024.
Yeah. I remember him talking about that.
Yeah.
So let's talk about on the continuous forming. This platform combines, of course, thermoplastic pultrusion. Maybe talk about how this differs from traditional pultrusion.
Yeah.
So it's usually limited to straight profiles.
Right.
So this is a little bit different.
Yeah, so there's a couple things that differ. The first is we're not handling wetting. We're using pre-impregnated laminates. So the wetting with thermoplastics usually is what slows down pultrusion, and it's because the viscosity is higher, and it typically decreases things like part thickness or overall size. So since we're not doing wetting, our process is effectively just a heat transfer process, and we're able to do parts that are quite thick and large, like the dowels are 3/8 of an inch thick. We're targeting 3/4 thick dowels eventually. The dowels are not curved, they're just straight. But since we're working with thermoplastics, I mentioned it's a heat transfer process. We can add other modules to the same machine in line. So, for instance, when we make rebar, we start by creating just a plain, straight, smooth rod, and then we have a second module on the machine that heats and applies rotation of a molding process to create the deformation that turns into the rebar.
So let's talk about. Obviously, you're targeting construction, infrastructure, industries. They historically relied on steel and concrete. What are some of the advantages that you're bringing to these sectors over traditional materials like that?
Yeah, so the CFRTP material has the same general value prop of composites. For instance, with the polydowels, composites don't rust, right? That extends the life cycle of structures. They're a fifth of the weight of a steel dowel, so you can typically, when you ship construction components made of steel, you're limited by weight, not volume in the trucks and containers. So we can fit five. You can typically only fit about 20 to 30,000 dowels on a semi truck going to a job site. We can fit over 100,000 by weight. Yeah,
that's amazing.
Beyond that, though, the manufacturing process, since we're using thermoplastics, the waste from the process it's a high performance feedstock.
Right.
So the offcuts from the machine we can put into a pressing process and turn into something like a ski boot or something like that.
Yeah. So we're talking circularity.
Yeah.
I mean, you can recycle. So there's a lot of it. What is the? Mention that again. A truckload. The difference.
Yeah, so typically construction components are weight limited in shipping, like a semi-truck. With steel plate dowels, you can fit between 20 and 30,000.
Yeah.
The poly dowels, they're 20% of the weight, so you can fit 5 times more.
So logistics, we're talking major cost savings. Outside of infrastructure, are there other markets that you're looking at?
Yeah, we call infrastructure and construction our beachhead. Even though some people think it's kind of a hard market to get into, it's our background, so it's what we know.
Right.
But what we consider to probably be our highest volume market is industrial manufacturing.
Right.
We've been working.
That's the heavy volume that you're looking. Yeah.
Right. Yeah. So one thing we've been working on for the past year or so is working with LFTD compression molders and injection molders to create stiffeners that go in the process.
Okay.
So think of LFTD molders will sometimes even use steel rebar or stainless steel reinforcement to make parts stiffer, lighter, stronger, heavier. We can create a reinforcement that's non-metallic, but it's made of the same polymer that they're molding with, so you get a diffusion bond between the stiffener and the part, and a stronger and stiffer part.
Okay.
Yeah.
Were you guys at, was it the Pultrusion show in Chicago?
Yeah.
Yeah, was that? Yeah, last year.
Yeah.
Okay. How did that go?
It was good.
Yeah.
A couple years ago, when we were at the University of Maine, our director keynoted that. We had a presentation on the thermoplastic rebar.
Okay.
Yeah.
So how's the show been for you guys so far? I mean, what's the, what's the overall, the discussions, the conversations that you're having with people that are learning more about you guys?
It's been good. So we're one of the finalists for the Startup Booster competition. Yep. We just pitched yesterday.
Yeah. How did that go?
I think it went well.
Yeah.
We're one of 20. I think they mentioned there were over 155 applicants. So we're pretty excited from a small state.
Sure.
Maine. Typically, the conversations we've been having are, what's new, because Europe is the composite innovation capital of the world, right? So thermoplastic pultrusion's been around.
Right.
People come up and they ask us what's new. And we get to bring up the scale we can achieve, the speeds we can achieve. We produce rod at 4 meters a minute, which is exceptionally fast for pultrusion. Part thicknesses increase. And the other part of our company is we're all structural mechanics engineers, so not quite civil structural, but material mechanics. So we can back up as we say, like, this is the future of structural materials. We can prove it with the engineering design and simulation. So we're finding that it is somewhat rare to have a company have kind of all of that in one spot. So people get pretty excited about that.
Yeah. So traffic's been good?
Yeah.
We were talking, I think, before we were recording about the some of your work under Dr. Habib Dagher at the University of Maine. and so you had some experience under his tutelage, and then we're talking about some of the the applications for composites and bridge structures and things like that. So you have some background under him.
Yes.
Under that. Yeah. So I know it's an exciting day for you guys. Day 2. What are you looking forward to the most today at JEC?
Well, the thing we're looking forward to the most is finding out how we did in the competition. Unfortunately,
of course.
that's not till the evening.
Yeah.
We're just we're looking forward to seeing more traffic come through the booth and get to share. We're going to try to target conversations today with the overmolding technology, the stiffeners for overmolding, and do a little bit of outreach. And we were kind of all confined to this since we have 2 booth locations to the booths yesterday. So we're going to try to create something of a schedule so we can get people out in the show and walk around. Yeah.
Fantastic. Well, good luck. I hope wish the best for you guys. But congratulations on being a finalist amongst a really top tier group. So good to see you again. Again, I want to mention your website at reformcomposites.com. Cody, thanks again.
Yeah.
Appreciate it.
Thanks for having us.
Yep.